Jeg har netop mødt og talt med Dara Dotz, som er en amerikansk kvinde, der arbejder for en organisation, der hedder Field Ready. Hun er faktisk designer, og det som hun gør sammen med den her organisation, det er, at de tager ud i katastrofeområder, Nepal for eksempel efter jordskælvet der, og Haiti også flere år efter jordskælvet, hvor de her steder de simpelthen ikke er bygget op endnu, og hvor der er dårlig infrastruktur, og det er svært at få for eksempel medicinsk materiale ud til de små primitive klinikker. Og det som de simpelthen gør, det er, at de bruger 3D-printere til at printe små, men utrolig nyttige ting. Det kan være reservedele til medicinsk udstyr, som står et eller andet sted, der ikke kan blive brugt, fordi det simpelthen mangler en lille dims. Det kan de så printe. Det kan også være sådan noget som en helt simpel ting, som klemmer til navlestrengen, når det er, at kvinder føder i de her ret primitive klinikker. Jamen står de så og mangler noget så vigtigt som en steril klips til at sætte på navlestrengen, så er det noget, som de også kan 3D-printe. Og Dara, hun har simpelthen også arbejdet med space-industrien for at få 3D-printere ud til rumstationer, hvor astronauterne så kan printe igen små dimser, som de har brug for. Og det har jeg altså snakket med hende om, så tag lige at kigge med her. So Dara, what are some of the ways that you can use 3D printing in medicine?
What we found with Field Ready, what we do is we've used a lot of 3D printing FDM, which is the single-use printer, primarily to make spare parts to get medical machines up and running again in disaster zones, post-disaster zones. And we've also used it to make medical disposables, such as when we were in Haiti making umbilical cord clamps, nebulizer adapters, and various other tools that nurses and doctors can use that they can't get access to traditionally and when they're cut off.
So these are good examples of how you can use 3D printing in the field, but if we move into the hospital and just very quickly look at some of the possibilities, I know that they're already going 3D printing on with organ printing, something like prosthetics.
Yeah.
What else would we see in the hospitals in the future?
Yeah, I think that the future hospitals in the future, I think will actually start to work with more distributed manufacturing. So instead of traditional supply chains where you have to order a million of something to get cost benefit analysis, you can now have your own systems to create what you need when you need them. So I think in the future it'll be a lot less shipping around and waiting for supplies, and perhaps a lot less waste as well. Instead of buying a million of something when you only need 2,000, you can now create exactly what you need. And it prevents redundancy. It also will mean that the nurses and doctors can actually create almost a customized thing for what they need. So I think that it'll really start to transform the experience and the access and the ability for doctors and nurses to innovate on the fly, which traditionally is not seen.
So customization and real-time printing is probably some of the important things. I've read that in the future we'll also be able to 3D print medicine in the pharmacy on the fly. So if you come in as an individual, you're gonna get like that particular blueprint that fits your disease, and the pharmacist can then print it.
Yeah, it's above my pay grade, but it's definitely in the works, and I think that customized medicine is really going to be the future, because generalized medications that are used for a million people aren't as powerful for the individual. So there's definitely going to be a lot of revolution in that area fairly soon, I believe. And also, I mentioned earlier prosthetics, and with 3D printing, we're also finding different ways of making lower cost prosthetics. Particularly, it's on the hospital, but there's a group in America called eNable, and they do low-cost 3D printed prosthetics for children. And it's been really revolutionary, because typically children, as they grow so fast, don't get prosthetics because it costs $5,000 or so, and they grow out of it. But with 3D printing, we can now make a number of prosthetics for under $30 each, and we can make them custom for each child instead of using the exact same hand for everyone. It's not as comfortable, it's not as functional. So now we found a lot of people taking action with this kind of manufacturing to customize things for children, which has been a really fun project to see unfold. And so I can see that in the future in the hospitals, also using 3D printing for just such things.
Let's move a little bit into the disaster areas, because I know that that's where you've been working a lot. You worked in Nepal, you worked in Haiti related to earthquakes and the problems that arise, not only in the exact situation when this earthquake is happening, but also in the years after, rebuilding the community and also helping in local clinics. What kind of role does 3D printing play in these areas?
Particularly in the areas that we've been, it's when after a disaster the supply chains are broken. It's very hard to get access. Roads are washed out. There are no planes that can drop in. In Nepal, there were no helicopters after the earthquake, so it was really a challenge to get people what they needed when they needed it. And a lot of times when things get shipped in, it's all exactly the same thing, but all the various clinics have different needs. So it's really played a role in fixing things. Actually, after disaster, when machinery breaks down, a lot of the medical machinery that's been donated is antiquated. So not only is it broken, people don't know how to fix it, and they can't get spare parts. So a lot of what our team has done in Nepal, primarily Abby and Ram, they've been going around to different clinics and hospitals, finding things that are broken and then fixing them. So they've done fixed a number of baby incubators, hospital beds, nebulizer adapters. So it's been really amazing to see what we could do, and also showing people what's possible, and then having them come back to us with even more exciting, interesting, useful use cases.
What seems to happen a lot in areas like that when supplies are scarce is that people have to come up with ideas because they simply just don't have any tools, so they have to make them. And I know that you have an example of a woman that worked alone, a nurse that worked alone in a primitive clinic, and she had to deliver 5 babies with 5 women during one night, and she didn't have anything to help her. What was it that she did?
So she had to deliver 5 babies in one night, and since it was no longer the sexy disaster, it was 2 years after the earthquake, she had no more donated supplies. So she had to, after the babies were born, she had to tie off their umbilical cords in a sanitary way. So all she had left were her gloves. And so she actually cut the fingers off of her gloves and then tied off the umbilical cords, which is a great hack, and necessity is the mother of all invention. Except that with the fingers cut off, she was now delivering barehanded to potentially HIV positive women. And that was just, devastating for me personally to hear that. And that's actually what got me on the journey to 3D printing, because I thought that not that we print the gloves, but that we could print the clamps, and because they're basic polymer. And actually this is one of the models that we made, that we started using and teaching people how to make in Haiti.
So this is actually a clamp that you can 3D print on the spot in Haiti, so that like someone that doesn't have any supplies, I guess that's just one of the things that you could 3D print. There would be other supplies that would be important, that would be really small parts that make such a big difference in the situation. This is what makes her able to cut off the umbilical cord without sacrificing.
Yeah, it's a way of tying it without sacrificing supplies. Yeah, so 3D printing's really been able to kind of augment. Well, it's not there. It can't make everything yet. It can make things such as clamps and other plastic disposables and things like that, which leaves the extra time and space and luggage and shipping for the things that are really needed, such as rubber gloves and things like that. We also worked on some wash and sanitation projects, making water spigots and fixing water hoses and adapting them so that people could get clean water to the clinics, particularly with the cholera outbreak in both countries.
So you worked in these disaster areas where it can be hard to get to because the infrastructure has broken down, and that's why 3D printing becomes relevant in this area. And another area where logistics can be difficult and where we don't really have the right infrastructure yet is space. Yeah. And I know that you also worked in space projects. And if we do become this intergalactic race that Elon Musk and many of us are hoping that we will become, what kind of role can 3D printing play in when we need to set up a new civilization on a new planet?
Great question. Actually, 3D printing is really interesting because the biggest thing is that you can make almost anything out of it. So when you go to a disaster zone or to space, you never know what you're going to encounter, particularly in these long-distance space missions. We have an idea of what's going to be there, but we're not going to know until we're actually on the ground. So the amazing thing I think about 3D printing, particularly in space, is the ability to make what you need when you need it versus having to spend many, many years planning and praying that a rocket will come. It kind of gives you some independency. And the other wonderful thing, I had the pleasure of working at Made in Space, is that we also worked on 3D printing with regolith, which is synthetic moon dirt, essentially. And that means that the biggest challenge is supply chain, right? So also getting the bulk material to turn into useful products. And so really focusing on building in situ, which is to build out of materials there, is really where it's going to revolutionize things, I think, particularly with 3D printing and building shelters and building bases.
And you already did a project where you actually put a 3D printer into space with astronauts. how was that? How could you help them out, and did they feel like it was something that was useful in their work?
Yeah, I actually got to work on the first machine. Main Space now has 2 machines. They just launched their fully commercialized printer, which is multi-material printing. The first one we sent out was a science experiment, and while we were working on it, actually the astronauts on board got so excited, they spent some of their very limited time just to play and learn how to use the 3D printer. So I think they could really see the benefit from it. We overheard the mission commander say that he wished he'd had a ratchet, and so we actually scrapped one of our files and made a new one on the fly on Earth, and then we actually essentially emailed it to the space station.
What is it exactly that happens there? Is the blueprint that you're emailing so that they can print it on the station? Or
so with 3D printing, you need to make on a computer a three-dimensional drawing essentially, which is a CAD file. And then you send it through a G-code slicer, which slices the image essentially in any one of 100 to 1,000 layers so that the printer actually knows what to create. And so we sent that completed file to the space station essentially, and Made in Space actually operates the printer from Earth. And so they sent it and then turned it on without the astronauts even having to do anything. And
so they just woke up and saw that the tool they needed
was
there.
Yeah, Butch, the mission commander, he actually literally just woke up while he floated over there and peeked inside, and there was a ratchet for him, and he was very excited. And it's very hard to surprise astronauts.
So what are the challenges in 3D printing in space? Because I guess that a part of 3D printing on Earth is that gravity it's a part of it, and we don't have gravity in space, so what happens?
Absolutely. Oh, sorry.
Just continue.
Absolutely. So one of the things is that heat doesn't rise in the same way. And traditional FDM 3D printers, they use gravity to lay down the object and to create. So we had to actually create a new way, discover how we could do that and print from any angle. And so a lot of that also had to do with the way heat's distributed, how the nozzles worked, and how we got it to adhere to the build plate. And I don't think it's quite public yet, but I will be happy to tell you once it's out there. But yeah, it was really amazing, a lot of work. The Made in Space team is an incredible group of young entrepreneurial engineers. And they have, when they started, they did over 400 flight parabolas, which is to say there's a giant plane that goes up really high and then kind of free falls to give the simulated experience of zero gravity. And so that's how they learned about the heat things and all the challenges of 3D printing.
And did they then have those like 15-20 seconds to work on the tools, and then the plane would have to go back up? And
Exactly. It was like 15 seconds of zero gravity, and then you have to hit stop and wait till and then it goes like another 20 seconds up and then falls again. And that kind of got silly, and they realized you can't really do a solid print for 15 seconds repeatedly. So what they did is they engineered the 3D printer to not just work in zero gravity, but in 2Gs as well. So now it's a very robust printer that can work in almost any angle.
So Dara, if we look into the future from here and the future of 3D printing and try to sort of put on the glasses of a hospital or someone that works in medicine or in care or also in these areas where it's hard to bring out tools normally, what will be the role, do you think?
3D printing? I think the role will be about, I think it'll be about giving power to the individual to create what they need instead of waiting and trying to find the right thing. They can actually then create what they need. And while not everyone's a designer, you can definitely work with people and create those tools and augment the skills they already do have on the ground. And I think that's really what's going to change. And while 3D printing isn't perfect yet, I think that it's starting to head that way, and I think most of the development is really, particularly with medicine, is really going to come through material, because we kind of have a limited amount of materials that we're doing additive manufacturing with now, and as more people in the material sciences developing new materials to use, I think that we're going to see a tremendous leap in how we can use additive manufacturing and what use cases, particularly in medicine, as people are trying to print 3D print organs, people are trying to 3D print skin for burn victims. It's not there yet, but I think it's definitely on its path, and it's really exciting. A friend of mine always says it's not just science fiction, it's science fact. And so it's very exciting to actually be in that world right now and see what happens.
So we're going to wish you the best of luck with 3D printing on Earth and in space. Thank you very much for being a part of the program.
Yeah, thank you so much.